Okay, so we're going to move on to our three variable systems of equations. And what you're going to see here is a lot of similar things to what we had before. You can have your independent, inconsistent, or your dependent system, okay? And the rules are the same as when you did the 2 by 2s. When you have your independent, that's your one solution. And when you have your inconsistent, that's no solution. And when you have an infinite, we're going to do the complete solution like we were doing on the 2 by 2s. All right. So if you look at this first problem here, this one's in what we call triangular form. And if you notice that this third equation here just has one variable, the second equation has two variables, and the first equation has three variables. So that's obviously a triangular form because it starts big and gets smaller. It's kind of like an upside down triangle, I guess you could think about it. And these are pretty straightforward. You just use back substitution to solve. So you want to start with your third equation, and you can solve that for z pretty easily just by dividing both sides by 2. All right, and that means our z value of our solution is going to be 3. So remember, you're working with three variables here, so you want to think about x, y, and z in your solutions. Now if I go to the second equation, I can use back substitution to put that z value in and solve for y. You're going to get a 9 here, subtract that over, which is 0, and then divide out your negative sign. So you get a 0 for your y, and then go to your first equation and back substitute what you know about the y and what you know about the z, and then solve for x. So this is going to 0 out, subtract the 3, and you're going to get a 4. So this is an independent system. It has one solution, which is 4, 0, 3. Make sure you always write it as that x, y, z point. And what we've done here is we've gone to three-dimensional, okay? And so we're no longer working with lines, we're working with planes, okay? Like not like an airplane, but like a plane, like geometry plane, like a flat surface. And so this is the one spot where those three planes come together. So let's go down to this problem here, which is a little bit different than the one we just did before because it's not given to you in triangular form. All right. So what you want to do on a problem like this is you want to create a 2 by 2 system. Okay, that's your first goal, and then you're basically going to work that kind of so you can get it down to using back substitution. So just a little bit longer of a problem here. So if you'll notice, this first equation has three variables, the second one has three variables, and the third one has two variables. So I'm going to call these A, B, and C. Let me actually redo that A. It doesn't look much like an A there. All right, so this will be A. And so if I take equation A and B and I can eliminate my y variable, I will get another equation that has just x and z in it. All right, and that will actually match equation C. All right, so let's just go through that. I think it's easier to see how it works when you just see a problem done. So ignore that. There's crazy things going on with my computer today. So equation A is 2x plus y minus z equals -8. And equation B is -x plus y plus z equals 3. And if I want to eliminate my y variables, then I need to multiply either equation A or equation B by a -1. So let's say I choose equation B. It really doesn't matter which one you choose, okay? So I'm going to do -1 times equation B. So equation A is going to stay the same. And all of the signs are going to flip for equation B. Let's see. Okay, so my equation B will now be positive x minus y minus z equals negative 3. And then if I draw a line and I add down the columns, the y's are going to eliminate. I'm going to get a 3x minus 2z equals negative 11. Okay, and I'm going to call this equation D. So if you'll now go back, remember, look at equation C. Let's write that over here. Equation C is negative 2x plus 4z equals 18. And equation D is 3x minus 2z equals negative 11. I have a 2 by 2 system, and that's what I was talking about before, is you're basically trying to get to a 2 by 2 system and 2 variables, 2 equations, and then you're just going to use the same skills you already know how to do from when you learned your 2 by 2s. So if I want the z's to eliminate, I need to multiply equation D by a 2. So I'm going to leave equation C the same and multiply equation D by a 2. So I'm going to get a 6x minus 4z equals negative 22. Draw my line, z's eliminate. You're going to get 4x equals negative 4, and then x will equal negative 1. Okay, so if we're writing out our solution, we know the x value at this point. And then you want to go to one of your equations, either C or D, to solve for another variable, which in this case would have to be the z variable. Okay, so I'll try to squeeze that here. So let's say you choose equation C. All right, so that's negative 2 times the x value, which we know is negative 1, plus 4z equals 18. You're going to get a 2 here. You're going to subtract that over, and you'll have 4z equals 16. Divide out your 4, and you get 4. So the z part of the solution is 4. All right, and then you want to go back into either equation A or B to find the last variable, which will be y in this case. So let's say you choose to use equation A. So that'll be 2x, and you know your x is negative 1, plus y minus your z, so minus 4, and set that equal to negative 8, and you're going to solve. So you're going to get a negative 2, you subtract the 4, that's a negative 6. You want to add that over, and you're going to get y equals negative 2. Right, so the y value of this point is negative 2. And there is your solution to the system. So like I said, as a quick recap, you're basically trying to work towards this 2 by 2 system. Okay, and then you're going to basically use the back substitution to solve. So you're combining a lot of algebraic skills together. All right, so I'm not going to do the whole problem for you, but I'll get you started on number 5. All right, if you want to make a 2 by 2 system, then decide what variables you want to eliminate. So let's say you want to eliminate your x variable. Okay, so you want to take equation A and B and eliminate the x. All right, and then you want to create a different pair of equations, so maybe equation B and C, and eliminate the x. All right, and then you will have a 2 by 2 system of y and z because you've eliminated the x. So there's a lot of different ways to work these, so if you want to try it a different way, of course, go ahead, that's fine. I was just giving you a suggestion of how you can get started, and I'll see you in the next video.